Now we're going to solve a system of equations using matrix methods, which is really linear algebra, and the calculator. So first, here is your system of equations. So here's the theory of what we're going to be doing. You have a matrix of coefficients. For example, here's the 1x. There's your 1. There's a plus 0y really here. And that's the 0y and the 1z. Okay, and then the negative 2x is this negative 2. So this is a coefficient matrix right here. Coefficient matrix. Then times the xyz equals 0, 0, 1 over here. And just briefly how that works is, to multiply matrix, you have a row times a column, and you add. So 1x, that's 1x plus 0 y 0y plus 1z equals 0. And that's that first equation right there. Okay, so that's how you multiply matrices. Row times column and add, and then do the next row times the column, add, and that would be equal to 0. And then the last row times the column, and that will equal to 1, and that produces your original system of equations. So that's your matrix equation right there. Now how are you going to solve it with the theory? You're going to multiply an inverse matrix here. This is your inverse. And you're going to hit it on the left side of this matrix and the left side of the matrix on the right side of the equation. Because in matrices multiplication, the order matters. So it's a linear algebra topic to find out what that inverse matrix is, but we're going to use the TI calculator to do it. So then, in the theory, an inverse matrix times the matrix itself will equal the identity matrix, and on this side you just have a product of two matrices. Now it's interesting that the identity matrix times by XYZ column matrix will give you the XYZ column matrix, because row 1 times the column will give you your 1x, that's x, 0 y, and 0 z. That's why you just end up getting x for the first one. When you multiply the second row times the xyz, you're going to get 0x plus 1y plus 0z, and that's how you end up with the 1y. So you really do result in this solution that your XYZ answers are going to be the inverse of the coefficient matrix times 0, 0, 1, and that's what we're going to put in the calculator. So we get out our calculator, and first thing we do is we go second matrix, and we get this, and we're going to edit the A matrix and make it be a 3 by 3, because that's what this 3 by 3 matrix is. And we're going to have the B matrix, we're going to edit that to be a 3 by 1, because that's a 3 rows by 1 column matrix over here. So first thing you do is you arrow over to edit, and you're going to edit number 1. That's the A matrix. If it's not a 3 by 3, you make it be a 3 by 3, and then that gives you blanks here. Then you can then enter in each of the coefficients one at a time, press enter, and it goes toggles through them, and I've already entered them in here. Then you're going to go back to second matrix, and you're going to edit, go over to edit, and you're going to edit the B matrix, which is the column answer matrix on the right hand side of the equation, 0, 0, 1. Not the answer matrix, but the original right hand side of the system of equation matrix. So that would be 2, enter that, and if that's not a 3 by 1, make it be a 3 by 1, and then enter in the numbers 0, 0, 1, just as it is over here. Then we're almost done. Just go to the home screen, second quit, and you want to go to second matrix to put in the A matrix, which is number 1. But we don't want the A matrix, we want the inverse of the A matrix, because that's the way the theory worked out. So there's this x to the minus 1 key, so you hit that, and then you just want to times by the column matrix that was the right hand side of the original system, 0, 0, 1. We already have that in second matrix, which is number 2, B, and when I enter this, I get the X, Y, Z answers, and in fractions those are, so we have the negative 0.065, negative 0.25, 0.0625 being the answer to your XYZ here, and those are perfectly fine answers. But in exact fraction form, if you want that, that's here. And so those are the solutions to the system of equations, and if you plug those in for x, y, and z, they would certainly work.